Well, hello and welcome to Module 3, Lesson 9, More Using If-Then Statements in Solving Equations. Yes, and if this lesson follows the pattern of the others, it's always this continuation lesson that is usually rather short. Okay, so we're going to try to do this run this lesson and do it pretty quickly. So here we go. Using if-then moves in solving equations. Okay, let's do this opening exercise. And I'm going to tell you right now, just be forewarned that this opening exercise may look ridiculously easy. Okay, because you're going to look at it, you're going to read it, and you're going to go, okay, I know the answer already. But what I want you to do is I want you to write an equation, develop an equation, write it down, follow all the steps, all the if-then moves. Okay? So go ahead and do it. I want you to pause and give it a whirl. Okay? Well, let me read it to you first. Heather practices soccer and piano. Each day she practices piano for 2 hours. After 5 days, she practiced both piano and soccer for a total of 20 hours. Assuming that she practiced soccer the same amount of time each day, how many hours per day, H, did Heather practice soccer? And I know some of you are going, duh. But beyond the duh, okay, the correct answer needs to include the equation and all of the steps. And I'll tell you right now, I will give you a number of steps. So starting from the first develop equation, 1, 2, 3, 4, 5, 6. 6 being the answer. 6 will be this, H equals something. Okay, that will be the 6th move. I want you to go ahead and do this. Be very diligent in doing this in this many steps. Okay? Come on back when you're done. Okay, so here's what I have. Here's what I came up with. Oh, I forgot to fill in the left-hand column there, but I'll continue here. All right, so first step was to create the initial equation. Okay, and that's this one right here. So where do all of these numbers come from? 5 days right here. Okay, 5 days, I'm going to multiply that 5 by, I need soccer hours and I need piano hours. Okay, so I need both of these. What I do have is I actually have the piano hours, which is right here. So that's 2. That's there. H is actually what they asked us to use for the soccer hours. How many hours per day did you practice soccer? Okay, that's going to be H. And then we have, there's our soccer plus piano is the same as H plus 2. 5 days worth of that equals 20 because she is saying that they're saying that she practiced for a total of 20 hours. Okay, and then just taking going beyond that, then we just do the distributive property right here. Distribute out the 5, so that becomes 5h plus 10 equals 20. Okay, and then we have then we're going to make 0 with the additive inverse. Okay, so we're trying to isolate that h in this case, isolate the variable. All right, and then we do that right here. What we do to one side, we do to the other. Okay, we have to do that there, and then we have 5h equals 10. Okay, and then we go ahead, and now we are actually making 1. Right, we're making 1 with the multiplicative inverse, right? Okay, right there. So then we multiply both sides by 1/5, because 1/5 times the 5h is going to give us h. Then 1/5 times 10 is 2. And again, hopefully you can do that. Just go like this. A lot of you are doing this very well. Very proud of you. 10 over 5, which equals 2. Okay, so h equals 2, which is a no-brainer if you want to do it from the beginning. Okay, but all of this is what I'm interested in you guys doing. Okay, we work with this easy stuff initially, and And then it could be more challenging, and you'll know. But it was pretty obvious, where it says that assuming she practiced soccer the same amount as she practiced piano. Well, she practiced piano 2 hours a day. I'm sorry, seems kind of silly, but anyway, yeah. So hopefully you did well with that. Okay, and here's that next problem. And what we're going to do after you do this problem, or you do this problem together, you're going to examine both of these equations, and we're going to talk about how they're similar and how they're different, because you're going to see something come up that that some kids will stumble over. But we'll go ahead and we'll look at it very carefully. Very, very important point to make. Okay. So here we go. Go ahead and do this one after I read it out loud for you. It says, over 5 days, Jake practices piano for a total of 2 hours. Okay, sounding familiar. Jake practices soccer for the same amount of time each day. Okay. If he practiced piano and soccer for a total of 20 hours, how many hours, H, per day did Jake practice soccer? Okay. Sounds the same. Okay. Sounds the same, but want you to go ahead and take it apart and do exactly what we did over here. Okay. Well, it's not going to look exactly like that, but set it up similarly and solve it similarly. Okay. So go ahead and do that, and come on back. Okay, so here's what I got, and hopefully you would have noticed right away. You might have missed it, and if you did, I'd like you to go back and well, let's go back right now and check it again. Here is that. Just take a look at how this was worded. It says, over 5 days, Jake practices piano for a total of 2 hours. Okay. He practiced piano over those 5 days for only 2 hours. Okay, so that is this number right here. So this is all his piano right here. His piano is that 2. Okay, because again, just like the last one, we're trying to put together a soccer time plus the piano time. Okay, all right, and then it says Jake practices soccer for the same time. For the same amount of time each day. Okay, so we're still talking about 5 days. And then again, we're using this, the hours, H, for soccer. Okay, soccer hours. So that's going to be 5H, because that's our unknown. And again, we have a total of 20 hours. So let's go ahead and look at those two. Now, if you look at this one, look at how this one started out. It was 5 times H plus 2. Okay, so 5 was being multiplied by both of these. Okay, because what you were taking the H, which was the soccer time, and the piano time together, adding those together, and then multiplying by 5. Okay, for the course of 5 days. Now, here he only practiced piano for a total of 2 hours. Okay, for the whole entire 5 days. So we have that total. It's done. What we don't know is about soccer. Okay, so that's a 5H. So you can see how different this is. It's not 5 times H plus 2. It's actually just 5 times H plus another 2. Okay, equals 20. So you can see it's going to be very different. And again, applying the same rules though. Here we go. Initially right here, I am making 0 by the additive inverse. Okay, so same on both sides. I end up with 5H equals 18. Then I'm going to make 1, okay, by H by using the multiplicative inverse of the 5 there. 1/5 times the 5H, 1/5 times the 18. I end up with this answer here. H equals 18 over 5 hours, which is the same as 3 3/5 hours if I want to use a mixed number. It's also, if I want to use a decimal, it's 3.6 hours, because 3 over 5 is the same as 6/10. Or probably the best answer I would say would be this one here, 3 hours and 36 minutes. Okay, 3 hours, 36 minutes. How do I come up with the 36 minutes? I have to look at my 3/5. And if I do 3/5 times 60 over 1, I can do this, and that is 1 and 12, and that is 36. Okay, so what I've multiplied is 3. I've taken 3/5 of 60 minutes. Okay, 3/5 of 60 minutes. And of course, that's going to be multiplication. Okay, 36 minutes. Alrighty. Okay, so here's example 1, and it has many parts. Goes up through G. It has G parts. Okay, so I'm going to go ahead and read it to you. I'd like you to go ahead and then, if you'd like to, just read through all of the parts of it, and then I'd like to actually go through it together. You have, looks like, quite a few. I mean, this lesson is almost over. Okay, as far as parts, but you have quite a few problems to solve in the problem set. So it'd be nice to let you get to that and do that on your own and see how well you do with that. But let's go ahead and do this example 1, and let's go through this together. I wish we could talk, but I'll have to just talk to myself here. So Fred and Sam are a team in the local 138.2 mile bike run-a-thon. Fred will compete in the bike race. Sam will compete in the run. Okay, Fred bike, Sam run. Fred bikes at an average speed of 8 miles per hour. Okay, and Sam runs at an average speed of 4 miles per hour. Okay, the bike race begins at 6, followed by the run. Sam predicts he will finish the run at 2:33 a.m. the next morning. Okay, so we have all of that. Okay, beginning at 6, he's saying that he will finish 2:33 a.m. the next morning. Okay, so first of all, now he's predicting this, but right here it says, how many hours will it take them to complete the bike run-a-thon? Okay, how many hours? All right, so go ahead and think about that and see what you can come up with, and then come back. Okay, so this one was just a simple elapsed time, which is not always the easiest thing, but if they are going to start at 6 a.m. and then end at 2:33 a.m. the next day, okay, we can go from 6 o'clock a.m. to 2:33 a.m. the next day. Okay, so we could just go 6 o'clock all the way to 12 midnight. We could do it this way. Okay, I mean, again, I don't know. Maybe some of you can look at this and know exactly how much time that is. But let's just deal with getting to 2 o'clock. Okay, and then 2 a.m. All right, this is 6 a.m. So if you go to 6 a.m. to 12 midnight, and 12 midnight is also known as 2400, okay, or 24 hours, a 24-hour day. This right here is going to be 18 hours, and then plus another 2 hours to get from midnight to 2 a.m. plus 2 hours. Of course, that is 20. So you have 20 hours to 2 a.m. Then you have 33 minutes left over. Okay, so what's 33 minutes as as a fraction is 33. Okay, but I'm not sure why they don't just put 20 hours and 33 minutes, but if we're going to turn this into a decimal or fraction, it's going to be 33 over 60, which is equal to 11 over 20. Okay, and then if we did this division, I mean, you could put 20 and 11/20 hours, 20 hours 33 minutes. I mean, truly, those are all good answers. But if we go ahead and put it into decimal form, okay, which is based on what they're showing me here on this key, is what they want. If I try to make a decimal out of that 11/20, hopefully we know how to do that. That's 11 divided by 20. Maybe some of you are just going to do this on your calculator. Okay, right there. So 20, that's going to be 500, and then another 5. So 0.55. 11/20 is the same as 0.55. So 3 different ways to write this. We could have put 20 hours and 33 minutes. Could have put 20 and 11/20 hours, or 20.55 hours. Okay, and probably the reason they want us to use this one is it's probably going to be easier to use in the rest of these problems. Okay, so let's look at B now. See what B asks us. Okay, so if T is how long it takes Fred to complete the bike race, in hours, write an expression to find Fred's total distance. Okay, so what we have here is we're just going to write an expression. We're not solving for this, we're just writing an expression. So Fred's total distance, okay, and we're using T for how long, because that makes sense. T is time. Okay, so write an expression to find Fred's total distance. Okay, and just to remember, there's one other piece of information we need, and again, there's a rate equation that is very handy, and that is D equals R times T, which means distance equals rate, some of you may have known this already, times time. Okay, very, very handy. Rate times time. Distance equals rate times time. Now, there is a place in the problem above where the rate is mentioned. That was my dog, Tessa, in the background barking. She wanted to get out. Close my door to my bedroom here to record, and she wanted to get out of the bedroom. So sorry about that. Anyway, yeah, so D equals RT. We've talked about this before, but no, it's going to come up again, and it's always nice to go over this again and again. Okay, so yeah, go ahead and write an expression. Okay, write an expression, and come on back. Okay, so if you did look up and look in the original problem up here, you would have seen that we found there was a rate that was mentioned for Fred on his bike, and that was 8 miles per hour. Okay, that was the rate. And you know it's a rate because it always has something per something. Okay, and you know we talked about rates in the past as we started the year off with rates. So yeah, so that's our rate, 8 miles per hour. So the expression we would need is we would use distance, okay, because we don't have a number for distance, because that's what we're trying to solve for. So that's why you can see we have put that D on the left side of the equation, because we're solving for it. D equals 8t, because we know this here, or if we didn't know this, we know it now, and that's right here. Because of this formula, the distance formula, distance equals rate times time. So we have the rate, which is 8, time we don't know, so we just put it down as t. And of course they've assigned the t right there for us, okay? So here's our expression. D equals 8t. If we plug in a time, we will get a distance, okay? Okay, so this part C here, I just want to remind you that this, if you notice, this problem is is progressive. Okay, it's a progressive problem, which means that it moves from one piece to the next. So as soon as you find a piece of information in one part, you know it's going to be used in the next part, and then then similarly. Okay, so what they want you to do here is to write an expression in terms of t to represent, to express Sam's time. Okay, to express Sam's time. So just want you to just go ahead and use information from the other parts to be able to express Sam's time. Okay, so look for what we know and what we have solved already for. Okay, so when we say in terms of t, we've already assigned t to Fred's time. Okay, and we said right here. So we said if t, remember up here in B, if t is how long it takes Fred to complete the bike race. Okay, t, that's right there. All right, we have t already, so we know that Fred is t. And then equals, this is going to be Sam's time over here. Okay, it's going to be Sam's time. All right, so actually we're going to write an expression. We're not writing an equation right now. But there's something else we know we've solved for. And what we've solved for already is the total time. Okay, that was our first question here, was how many hours will it take to complete the entire bike run-a-thon? That was right here. Okay, we solved for that. So we know if we take that total time, and then we subtract away Fred's time, that will represent Sam's time. Okay, so we've solved for the total time, the 20.55 hours. We've been told that t is going to represent Fred's time. So to get Sam's time, because they're both, they're going to run, and then they're going to, one's going to run, one's going to ride, then this would be Sam's time is just total time minus Fred's time. Okay, now here's where it gets fun. I say fun, but also can be a little bit challenging. Okay, but just understand that everything you need, you have. Okay, you have been solving for information through A, B, C, and you're going to use what you have solved for to do this right here. So what we're going to do is we're going to write another expression. So D is asking you to write an expression in terms of t, okay, that represents Sam's total distance. Sam's total distance. Now you remember when we did Fred's total distance, remember we used that expression, D equals R times T, distance equals rate times time. Okay, so that means you need to, and I'll give you the hint here, you need to find a rate from the problem, and you need to find time. Okay, what are you going to use for that T? Okay, battle that out, go back and look and see what you can come up with. It's not going to be super neat looking. It's going to be different. Okay, something you've probably never seen before or used before, but it's interesting because now you'll start to see where some of these problems that we create or given to you to solve, where they actually come from. Okay, I haven't written anything down yet because I want to actually go ahead and look for this information. So we're going to have, of course, the expression is going to start off d equals, okay, because we're solving for Sam's total distance, all right? So now we need a rate. And what rate do we know of? Well, if we go back, oh, I'm hitting the wrong thing. If we go back, we go back to our original problem, we will see a rate for Sam, and we can see that right here in my big mess, 4 miles per hour. Okay, so Sam's going to run at 4 miles per hour. So it's going to be 4 times something, okay? Now we need to find that t. Where do we have that t? Okay, we have that t right here. Okay, write an expression in terms of t to express Sam's time. Okay, we have his time right there. So what you will do then, you will actually take that expression and you will put it in parentheses. Okay, all right, and there you go. You have that. Now, of course, if you look at it closely, you can see that that can be simplified. And again, let me just clarify where I got this from. This 4, of course, d equals, because we're trying to solve for Sam's total distance. 4 was the rate. Okay, and again, let me put this back up here, but I need a little bit more room. Again, this is our master expression or master formula. D, distance equals rate times time, just a very strong physical science, physics formula in terms of motion and all that. And you'll be doing a lot of that next year in 8th grade, those of you who do physical science next year. Okay, so D, the rate, the R was 4, okay, and that came from the beginning of the problem, the 4 miles per hour he was going to run. And then the time, okay, we represented, because we don't know all this, but we represented his time right down here, okay, right down here. 20.55 minus t, because if you remember, that was the total time it was going to take minus actually Fred's time, okay? Then we went ahead and so we wrote it like that, and you can see what's really interesting is that you've probably seen many problems that have looked like that, and you can see what all these numbers and figures and stuff, they all come from somewhere, right? So what we can do then is we can actually do a little distributive property. Okay, we can go ahead and multiply this. Okay, multiply 4 times 20.55, and if you do that, and you can go ahead and do the math if you want. If not, just look at mine here, and it's 82.2. Okay, that's 4 times 20.55. All right. And then, of course, 4 times t, so this will be minus 4t. Okay? So now we have d equals 82.2 minus 4t. That is how we can determine Sam's total distance, and that's our expression right there for Sam's total distance, okay? And actually the expression, we don't actually need this, but I mean that's implied, okay? But that is the expression right there, 82.2 minus 4t, okay? And of course that t being Fred's time. Okay, so E asks us now to write, oh, now we're to an equation time. The fun begins. Write and solve an equation using the total distance both Fred and Sam will travel. Okay, so write and solve an equation using the total distance Fred and Sam will travel. Okay, again, you're going to be actually at the end of all of this, you're going to have an answer, an initial answer of t equals. Okay, so and then we're going to be able to use that to find out. And that of course is Fred's time. We can't lose, try not to lose sight of the fact that this t, because we're talking about this one problem still, this continual problem here, okay? And remember that t was Fred's, let me just erase that part right here. That's right here. Remember now. Very, very important that this t is how long it takes Fred to complete the bike race, okay? So that t can only stand for one thing. It can't be for Fred's time and Sam's time. Just can't be, okay? It stands for Fred's time, okay? So we're going to solve for Fred's time because that's what we've been using. We've been talking in terms of t the entire time. We know Fred's time is t. We know Sam's time is 20.55 minus t. We know all those things. So put all these bits and pieces together and solve this problem right here. Go ahead and give it a whirl, put it together as much as you can, and then come on back. Okay, so maybe you've just pained through this, had a little bit of difficulty getting started. So let's get started together. So if we're going to write and solve an equation using the total distance both Fred and Sam will travel, we need to come up with the equation we're going to use. And we are going to use this one here, okay? Distance equals rate times time, okay? That d equals r times t. And we can do it that way, or we could flip it, because the truth is we know with multiplication, r times t is going to equal d. That's the same. It's always good to have this number on this side, on the right side, okay, and your variable over here. We know our variable is going to be t as a variable, so let's put it on the left, okay, and then we have a distance number already. You might have forgotten about that, so I'll tell you the truth, I had, okay, and that distance, remember, was, maybe some of you didn't, but that was this here, remember, 138.2 miles. So if we go ahead and write this RT equals D, okay, because that's what we're going to be doing. RT equals D, which is the same as D equals RT, okay. Let's go ahead and we're going to put equals here, and then 138.2. That's the miles. That's the total miles, okay. What's going to equal 138.2? Well, we've got, we created an expression here for Fred's distance, and that was 8t. So here's Fred, okay, that's Fred. All right, so we got, because Fred's distance plus Sam's distance equals total distance, which is, just makes sense, okay. Total distance. So that just makes sense. So that's what we're actually doing here. So we have Fred's distance plus, remember we had our Sam's distance, and that was right here, right above. Let's use this one. I mean, you could use this one, but this one here is simplified. Plus, and we can, let's just go ahead and put that into, we don't have to. Let's just go plus 82.2 minus 4t. That's really, really messy. Okay, I don't think you need this anymore, because that's it. Just wanted to show you what we're doing there. Okay, let's just open this up a little bit more. Let's make it a little bit nicer. Okay, so our initial equation is going to be 8t, which is Fred's distance, plus 82.2 minus 4t, or why don't we just do like we like to do. Let's use sums. Plus negative 4t equals 138.2. Okay, 138.2 again is that total distance that we have already. We did not need to figure that out. We had it. Again, it's right here. Okay? All right, and of course I could leave you on your own right now because you have all the tools you need. Okay? You're going to make zeros. You're going to make 1. You're going to isolate that t variable on the left, and you're going to come up with an answer. And I want you to try this on your own. So solve for t only, and then we'll, because we know t is going to be Fred's hours, okay, Fred's time. Okay, that's just Fred's time. Okay, that's going to be t equals, and then we can do Sam's time together. I just want you to get this t equals. So go ahead and pause and give it a try. Okay, so here we are. I am very, very confident that that a good deal of you out there will have gotten this one correct. Okay, so as we started with, we have our initial equation that we put together with the information from the problem and the information we actually solved for beforehand along the way. Okay, and then making zero right here. Making zero, just getting rid of that 82.2 from that left side, okay, and doing the same on this side, the right side. We end up with this. So now we have 8t, of course our 8t stays, plus our negative 4t equals 56, and that of course is 138.2 minus 82.2. Now if we combine 8t and negative 4t, we end up with 4t, and that equals 56. And then we multiply by the reciprocal of 4, both sides, and we get t equals 14 hours. And what does that t stand for? That t stands for Fred. So Fred's time equals 14 hours. Now we can use that and we can solve for Sam's time, and we're going to need some information. And the first bit of information we need, of course, well, we have 14 hours for Fred, but we also know, of course, that the total time was 20.55 hours. We had that. Okay, so if we do 20, excuse me, 0.55 minus 14, because that's Fred, then we get 6.55 hours. And this is Sam's time. Okay, so these are our two answers here. We have Fred's time equals 14 hours, Sam's time 6.55 hours. Okay, we're not done with this problem yet. Great problem, so thorough, so much to do. Hopefully you're getting things right along the way, and hopefully you're growing in your knowledge of algebra. Okay, well let's go ahead and solve this one here. So how far, this is part F, how far will Fred bike and how much time will it take him to complete his leg of the race? Well, you know, I don't know why they asked this, but we know this part already. How much time will it take him to complete his leg of the race? That is right over here, and that's 14 hours. Okay, so we know that part. But just solve for how far will Fred, how far will he bike? Okay, and again, go ahead and apply your distance, rate, time. Okay. Okay, to solve, so if we're going to go ahead and apply the d equals r times t expression or formula, okay, we need to fill in whatever we have. That we're asking about how much time. Oh, you got that already. How far will Fred bike? We're trying to find how far. Okay, we know his time and we know his rate, and again, these are things we've solved for already or been given. Okay, we solved and we found out that 14 was his rate, and no, it's his time. Okay, so we have d equals rate, which, if you remember, was 8 miles per hour. Okay, 8 miles per hour right here. Okay, so if d equals rate times time, then d, in this case for Fred, equals 8 times 14, which equals 112 miles. Okay, so not difficult at all. Now that we've done so much of the hard work, all we have to do is use our distance, rate, time formula to solve for many things. Okay. Okay, so the last question here, and I want you to go ahead and do it yourself. How far will Sam run? And of course, and how much time will it take? We know that already. I'm not exactly sure why they're asking this question, but you have that already. Okay, how much time it will take. So go ahead and apply the d equals r times t formula to this problem and solve for how far will Sam run, and come on back and see if you're right. Okay, so for Sam, trying to figure Sam's out, just took another extra step, because if you remember, this was our expression there for Sam, okay? Because his distance, and again, d equals r times t, 4 miles an hour being the rate, and his time was represented by 20.5 minus t, of course, which was Fred's time. So if we go ahead and plug in that 14, we end up with this. Okay, 4 times 20.55 minus 14. All right, if we go ahead and distribute out, we end up with this. Actually, we don't need to distribute. We can just go ahead and do the subtraction within. Okay, then we get 4 times 6.55, which gives us 26.2 miles. And for those of you who are familiar at all with running, you know that that is the length of a full marathon. Okay, so Sam is going to run a full marathon. Okay, we're going to. Okay, so I was just talking a lot. I went through this whole problem, this whole first part, without turning it on. So I'm going to say it all over again. That doesn't mean anything to you, but anyway, that's why everything's all written on here. Yeah, so this example too, Shelby is 7 times as old as Bonnie. If in 5 years the sum of Bonnie and Shelby's ages is 98, find Bonnie's present age. So we're trying to solve for Bonnie's present age, okay? Use an algebraic approach. And if you want to use this chart here, that's what I was talking about before, I'll set it up for you. And you could put here, this would be Bonnie, okay, and this would be Shelby. All right, so actually, why don't we do that? Why don't we fill this out together, and then I'll set you loose to solve for Bonnie's present age, because this is really important doing this type of thing. All right, this chart's really helpful because you can create expressions on this chart for all these different things, for Bonnie and Shelby's present age here, and then Bonnie and Shelby's future age over there. And we're going to have expressions. Of course, this isn't going to solve anything quite yet, but we have the expressions we can use to plug into our equations, okay? So for Bonnie, we are solving for Bonnie, okay? So we can just call Bonnie X, all right? So Bonnie's present age is X. Shelby, we'll give you a little time to figure out what would Shelby. And again, everything we write down here is going to be in terms of Bonnie. All right, and yeah, hopefully you figured it out. You saw over here the first line of the problem says that Shelby is 7 times as old as Bonbon. Okay, so that's going to be 7x. Okay, so Bonnie is represented as x, Shelby is represented as 7x. Okay, now future age, how long in the future? Well, it just says 5 years. Okay, in 5 years, if Bonnie is x today, in 5 years, she will be x plus 5. Shelby will be 7x plus 5. Okay? You and me, in 5 years, will be whatever our age is, plus 5. Okay? So there we go. Those are your expressions for their ages, present and future. Go ahead and do this algebraically. And come up with an answer of x equals. Okay, so here we go, using all of these expressions here. Okay, we can solve this. So we had x plus 5, and again, we're talking about future now. Actually, we don't really need those first two, but we don't need the present ages. Present ages just helped us build the future age. So we want to find out if in 5 years, so in 5 years, the sum of their ages is going to equal 98, then we're going to need the expression for Bonnie's future age, which is right there, x plus 5, and Shelby's future age, which is 7x plus 5. So these treated separately, this is Bonnie's future age, Shelby's future age equals 98. Okay, so that is our initial equation. And now we just go through those wonderful algebraic steps that help us to solve everything. Okay, we combine like terms here. The x's, the x and the 7x equal 8x, and then we combine the 5 and the 5 is 10. Keep our 98. Now we're going to make a 0 here, get rid of that 10 on this side by adding the additive inverse. Same on this side. We come up with 8x equals 88. Pretty obvious to see what x is going to equal, but let's go through the steps anyway. Multiply by the multiplicative inverse of 8, both sides, and we find out that Bon is 11 years old. 11 years old. Okay? And I could also ask you, how old is Shelby? And now all you need to apply to Shelby is you could apply this one here, this present age. So Shelby, if she is 7x, she is 7 times 11, which equals 77. Okay, I know I didn't. This question didn't ask that question, but I just did. Okay, well that is it. You know what they have us doing in the end of this is a game, and I might bring it to class. We could play it in class. I'm sorry, I thought this lesson was going to be a lot shorter, but there was actually a lot of information anyway because we did a lot of these things together. Okay. Hopefully you learned a bit, and just to know that you know, we can take information from oh, I don't like this blank page, I'm sorry. We can take information from a problem and we can work wonders with it. Okay, if you're very patient, okay, like with this problem here, okay, actually not this one, but this one here, and we had several parts of this one, each separate part leading to the next part. Okay, and we'll practice with some of these in class. So hopefully you enjoyed this and learned a lot. I'm sorry, you got your problem sets and exit tickets to do. Go get it. Bye.